Hello, pre-calc. Today we're going to take a look at our very last lesson in Unit 1, transformations. And this is something that should feel a little bit familiar. We're going to kind of go over all of the pieces just in case. Transformations. There are 3 types of transformations we can do to a function. 1.7. So what I'm going to do is kind of write a really big rule up here at the top for all the different types of transformations. You can see there are 3 different types, but 6 like mathematical, like in the equation, you will see the transformation, but three different types. So I'm going to write the rule up here, and then we'll do 4 little examples on it. All right, so this is for any function, wherever you start, where I start with any function f of x. And how you're going to transform it will look like this. And I'm going to try to color code a little bit so it gets even more clear. Okay, so I'm going to have negative a times f of, instead of just f of x, I'm going to put in here a negative b x minus h plus k. K is a little squished in there, but I think it's one of the easiest to spot. All right, so looking at this rule up here, from here to here, there are 6 things that are different. There's a negative sign, there's an a and a b, so 1, 2, 3, 4, and then this h and this k. Those are the 6 things that have changed. So they all do a different thing. So the negative signs, let's start with that. So I've got a negative all the way out front or a negative inside. What's the difference? These are both reflections. So this is going to take my function and reflect it. This is going to be a reflection. But because this is outside of the function, outside of the f of x, it's going to affect my y values because it's happening outside of the function. So if it affects the y values, it's going to be reflecting over the x-axis. If that negative sign is like multiplying itself here inside the function, that means it's only affecting my horizontal x values. That's going to be a reflection over the y-axis. Okay, reflect over the y-axis. So those 2, nice and easy to spot. Okay, then the h and the k. So if I've got this plus k, usually it's at the very end. Sometimes with trigonometric functions, I don't know why. I've seen this at the very beginning of the function too, like 2 plus blah 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 blah. Same idea. Like if it's being added or subtracted to the function as a whole, this is going to be a shift and a vertical shift. It's going to move me up if it's positive, down if it's negative. This is going to shift me up if it's positive, down if it's negative, just like it says. And then this h in here, also a shift. But a little sneaky, notice in the rule it is negative. So we're actually going to do the opposite of whatever it says here. So if it is negative, we are going to go in the positive direction. And if it is positive, we're going to go in the negative direction. And it's just however many it says. That's not fancy, like just whatever number that is, you're going to shift that whole function left or right. Now the A's and the B's, these ones are, I don't want to say the trickiest, but they're kind of visually, they look pretty similar, so it's hard to distinguish between them. So again, like this one, because I'm outside of the function with this a, this is going to affect my y values. So it's going to be a vertical, sometimes they call it a dilation, a vertical dilation. But if this number is bigger than 1, we're going to call it a stretch when a is bigger than 1, and a compression when a is between 0 and 1. Again, well, if it's negative, if it's a negative number, that's just a reflection and then whatever this is. So that's why it's not less than 0. So I want you to think about kind of with the vertical stretch and compression, think about a tree or a plant. And when the sun is out, it's going to vertically stretch up, or compress. It's going to get taller or shorter. Like those are kind of my describing words. Now B, this is I would think from what I've noticed, the least like used day to day, because you can do a lot of things with this stretch and compression. But if I want to make something wider or thinner, like horizontally, that's when I'm going to use this B. So it's going to be a horizontal stretch when the function is being pulled like away from the y-axis. So it's going to be kind of opposite. So it's a stretch if B is between 0 and 1. And then if it's a compression, that will pull this graph closer to the y-axis. It's going to be when B is bigger than 1. So it's kind of the opposite from vertical. There we go. So these are all the different ways I can move a function. These are all the different ways, kind of the like less official terms, if you ever hear, would be like a flip. This can be, like I said, a dilation. And then this one could be called like a slide, something like that. So there are kind of looser terms as well. All right, let's do an example. I feel like this is hard to really grasp without seeing some numbers. So first, let's see. I'm going to do my parent function of the cubic graph. And then let's write a transformed g of x function. So let's say g of x is -1/2 x minus 2 to the third. And the question is, what transformations have happened here? What transformations have happened? So if you're looking at this equation carefully, notice that there are 3 things different. There is no like sneak to that. That means there are 3 transformations. Each of these letters or negatives do one thing. And because I have a negative multiplying, a half, and a 2, 3 things have happened. So what I recommend is pull open Desmos and kind of look at these one at a time. So first, let's look at this negative sign. It's out front. It's for sure a reflection, but let's just take a look and see what type of reflection it is, right? So if I've got my x to the third function and I have negative x raised to the third, that's going to be a reflection. This one's actually really difficult to tell what type. It'll look the same whether you flip it horizontally or vertically. But this one's going to be a reflection over the x-axis. And then separately, right, now I'm going to go 1/2 x to the third. So it's pretty subtle. I actually might look at it without the reflection too. So you're just looking at one thing at a time. And this 1/2 is outside of the function because it's not in those parentheses. And vertically, it's looking a little shorter than the green function. Green function is my parent. The red function looks a little more like squished or compressed in the vertical direction. So that one is a vertical compression by 1/2. You can tell that up here because it is between 0 and 1. And then the last one is, where does that 2 move us? Okay. So I'm going to, again, like just look at one thing at a time. So I'm going to go in parentheses, x minus 2 parentheses. Okay. And looks like that has shifted me to the right 2. And again, you can tell that using this because that 2 was inside my parentheses and it's negative. To the right 2. Now, if we put those all together, then it'll have like your full function. But I find it easier to look at one piece at a time. So it's hard for me to look at this and say, these are the 3 distinct things that happened. All right, next one. Let's say I have a square root function. This is my favorite function. F of x is the square root of x. The square root function kind of looks like its sign. It kind of has that shape. And let's say I've got my g of x is the square root of negative x minus 3. All under the root there. So now looking at this, how many things changed? 2. 2 things changed here. I've got a negative and I've got a minus 3. But the reason I wanted to put this one on here is this looks like a reflection and a shift to the right. But because up here in my rule, it's got these parentheses around x minus h, and this doesn't, I want you to think like this b had been distributed to those 2 things. So if there is no parentheses in here, but there is that negative hanging out here, or a number, if there's no parentheses, it's been distributed. So let's take one step back and rewrite this. I'm going to undistribute this negative. And if I take out a negative here, I'm just left with x. Take out a negative, I'm left with plus 3. These 2 things are exactly the same, but this one tells like the truer story with our rule. So this one's going to be a reflection over the y-axis, and I'll show you what that looks like in a second because it's inside the function. And this is going to be a shift to the left. 3, sorry. To the left 3. All right, let's look. So I've got the square root of x. There's my square root function. And then if I were to type in the square root of negative x minus 3, notice this function has flipped over the y-axis, like it's facing in the other direction. That's what that negative sign does. And then if I put a minus 3 next to it, it moves to the left. It moves in the left direction, even though that's a minus. And it's because if I put the parentheses like we just did, kind of undistribute that 3 or that negative, you'll get exactly the same thing. So use your Desmos calculator to really, really check what movements have happened. All right, 14 minutes. Let's do one more example then. No, let's do 2. They're both kind of weird cases, so I want you to see both. All right, I'm going to do a little bit of an opposite thing now. I'm going to give you, we're going to start with the sine of x parent function, and I would like you to do 3 things to it. Reflect it over the x-axis, I would like you to shift it to the left by pi over 2. And I want a horizontal compression by 5. Okay, so what I'm going to do is I'm going to take kind of my shell of my function and just kind of write it big so I can add a lot of things to it and just do one of these things at a time. You can check each as you go in Desmos if you want. So a reflection over the x-axis, that's going to be outside of my function. So negative goes all the way out front. To shift something to the left, pi over 2, that's going to be an x plus pi over 2. I'm leaving some space here because there's something else horizontal happening. But to move something to the left, it's plus. And then a horizontal compression, that's going to be this number right here, by 5. And that's not going to be sneaky. You don't have to like reciprocate it or anything. Whatever number's there, that's there. This is a perfect answer. You could leave it like this. Another choice could be distributing that 5, just kind of like what we did up here with the negative. So this would be 5x plus 5 pi over 2. Both of these are perfect answers. Okay, and for my very last example here, I don't always have to start with a parent. So let's say I started with a rational function here, and I wanted you to do a vertical stretch by 2 and move this function to the left, I don't know, 5, something like this. So a vertical stretch by 2, I'm going to just, same idea, I'm just going to write out my function exactly as it was, kind of the shell of it, and then I'll add these two things in. So a vertical stretch by 2, that's going to kind of multiply outside the function. And to move something to the left, that's going to be inside the function. Look wherever x is. And to move it to the left, I want to go plus 5. Something like that. And this one you would for sure want to simplify. So multiply the tops here. This will be 8 over negative 2 plus 5 is 3. Take a look at the visual of this too. If you ever want to on Desmos, you can also pull up a table by clicking that gearbox and then just clicking table. And you can see that every x value here, for every x value that there is, the y value doubled. So you can always take a look at the table and the graph. Cool.